Okay, so we're going to look at solving rational equations, and these rational equations that you're going to have here will lead to quadratic equations. In a previous lesson, they led to linear equations. Now they're going to lead to quadratic equations. And just as in the previous lesson, remember the steps. So you're going to find the least common denominator of all the rational expressions in the equation. You're then going to multiply both sides by the least common denominator. You're going to solve the resulting equation, and then you're going to verify that the solutions is or are not restricted. Okay, so let's look at number one. So in number one, you have this rational equation. Now remember, rational equations is made up of rational expressions, and a rational expression is a polynomial divided by polynomial. So all these are polynomials. So that denominator right here, where you see that 2 is 2 divided by 1, so the denominator is 1. So all these are polynomials. So the first thing you want to do, though, before you find the least common denominator, is you want to make sure that all your denominators are in factored form. So in this denominator, we see that x plus 1 is a linear factor. It's a binomial, but it's linear, and the GCF is 1, so there's not much else I can do here. This denominator here, that's 1, so there's not much I can do there. And then over here, see this x squared minus 1? That's the difference of two squares. And so right away, I recognize that I can factor this. So I can factor this as x minus 1 times x plus 1. All right, so that was the first thing you have to do before you find the least common denominator. Now remember, your least common denominator is a product of all the factors in your denominators. So my first factor I see in that denominator right here is x plus 1. So it must be a factor of my least common denominator. Because remember, the whole purpose of multiplying both sides by the least common denominator is to clear those fractions, to clear that denominator. So you want this to be a factor of 1. Well, if that needs to be a factor of 1, then it better be in the LCD. The next one's a 1, right? Well, 1's already there. It's understood to be right here. And then the next factor is x minus 1. So that has to be in the LCD as well. Remember, don't put a comma here. Some of you have a habit of putting a comma. LCDs are not separated by commas. LCDs are, the factors are separated by the multiplication symbol. So don't separate the factors of the LCD by commas. All right, that's not indicating what the least common denominator is. The least common denominator is a product of all your factors. The next factor I see is x plus 1, but I already have it. Don't list it again, because if you list it again, then it no longer becomes a least, it becomes a common denominator. That's not the least. And then if you do that, then it's going to make this whole process right here extremely challenging for you to deal with. All right, so always find the least common denominator. All right, so there's the least common denominator. So the least common denominator is x plus 1 times x minus 1. Now the next thing you need to do is find the restrictions. So the restrictions, remember, when dealing with a rational equation, is the restrictions come about when, for the values of x or the values of the variable, because it doesn't always have to be x, the values of the variable that makes this rational expression undefined. Well, rational expression is undefined when the denominator is 0. So all you have to do is look at the denominators, the factors that are in the denominator. So this first factor I see is x plus 1, and the question becomes, where is that equal to 0? Well, x plus 1 is equal to 0 when x equals a negative 1, right? So there's one of my restrictions. So x cannot equal negative 1. The next one's a 1 right here. Well, that's not a variable expression. That's a constant. 2 divided by 1. This one's a number. 1's never equal to 0. Let's go to the next one. The next factor I see is x minus 1. So the question becomes, where is x minus 1 equal to 0? Well, if I add 1 to both sides, solving this linear equation, I get x to be 1. So that's a restriction. Because if x is 1, 1 minus 1 is 0, right? 0 times, and then here, 1 plus 1 is 2. 0 times 2 is 0. 12 divided by 0 is undefined, okay? And then for that one, I already dealt with. That's this one right here. So there are two restrictions, 1 and negative 1. Okay, now let's go ahead and do the next step. And the next step is to multiply both sides by the least common denominator. So let's go ahead and do that. Now notice on the left side here of this rational equations, there are two rational expressions. I'm going to put that in parentheses. So I'm going to say 3x divided by x plus 1 minus 2 equal, all right, so now I'm going to multiply both sides by the least common denominator. X plus 1 times x minus 1. X plus 1 times x minus 1 times this fraction. Now, whenever you rewrite this, don't write it as x squared minus 1. Use the factored form. It makes things a lot easier for yourself. And the reason is because if you use the factored form for the denominator, you'll notice right here, all these factors divide out with all these. Okay, so the next step is now I have to get rid of those brackets. So to do that, you have to use a distributive property. So the LCD times that first fraction, so x plus 1 times x minus 1 times 3x divided by x plus 1 minus, and then the same thing here. So the LCD times that second fraction, except I'm going to put the 2 in front. So it'll be 2 times, and then x plus 1 times x minus 1 equal. Now, since I'm running out of room, I'm going to go ahead and reduce here first. So the x minus 1s divide out, you're left with factors of 1. The x plus 1s divide out, you're left with factors of 1. Now remember, like we mentioned earlier, the whole purpose of multiplying by the LCD is to get these denominators to be factors of 1s. And now they are. 1 times 1 is 1, so that's a 1 right here. All right, now look at what I have. I have a 1 times a 1 times a 12. That's a 12 here. 1 times 1 times 12 is 12. So that's what you're left with on the right-hand side. Okay, reducing on the left side, I can see that the factors of x plus 1s divide out. And that's it, right? So now look, I have, if you look at just right here, I have a 1, a factor of 1, times x minus 1 times 3x. And so I know that multiplication is commutative, so I can multiply in any order. So I'm going to say 1 times 3x first, since that's a monomial, is 3x, and then multiply by this binomial, x minus 1. So this right here, I can write as 3x times x minus 1. Minus, and then I'm just going to rewrite everything else over. 2 times x plus 1 times x minus 1 equal 12. Okay, now look at this right here. I'm going to go ahead and kind of cover up this part here. And so if I cover up that part here, you can recognize right away that I have a monomial times a binomial, so I can use a distributive property, right? So 3x times x is 3x squared. 3x times a negative 1 is a negative 3x, okay? Now over here, look at what you have. So you kind of have like 3 factors if you think of this as a negative 2. A negative 2 times x plus 1 times x minus 1. All right, you got to be careful, because what some students will do is they'll distribute the negative 2 into both of those parentheses. That's not true. So if you multiply from left to right, you got to say negative 2 times this first, and then all of this times this. So that confuses students. So what some students do is they'll recognize this. They'll say, well, I'm going to go ahead and multiply those 2 binomials out first. And you can do that. That's fine. So if you cover that up, notice that when I multiply the 2 binomials right here, I'm going to get x squared, first times first, FOIL method, first outer, inner, last. The outer is a negative x times a negative 1 is a negative x. The inner is a positive x. And the last, 1 times negative 1 is a negative 1. All of that, though, is in parentheses because that's being multiplied, see this multiplication right here, by negative 2. So that's what you have. So this is this. See that? Now, before you distribute, make things easy on yourself. And don't forget, that's equal to 12. Before you distribute, make things easy on yourself, because notice a negative x and a positive x is 0, right? So rewrite it. So here's what I have. I have 3x squared minus 3x minus 2 times, and then this just becomes x squared minus 1. X squared minus 1. And it kind of makes sense. I'm going to get x squared minus 1 because notice these 2 binomials are almost identical except for the signs, positive 1, negative 1. And from experience, you know that when you see something like this right here, when you FOIL, becomes the difference of 2 squares. That's what you get, difference of 2 squares. Equal 12. All right, now let's go ahead and distribute here now. So when I distribute, I get 3x squared minus 3x. A negative 2 times x squared is a negative 2x squared. Let's get negative 2x squared. A negative 2 times a negative 1 is a positive 2 equal 12. Combining like terms, I have 3x squared and a negative 2x squared is x squared. A negative minus 3x and then plus 2 equal 12. All right. So I have this quadratic equation. So I want you to notice that I went from a rational equation, right, to an equation that has no longer any fractions in it, but is quadratic. Okay, all these are quadratic equations. So to solve a quadratic equation, see, I'm at this point, you got to put this in standard form, so I need 0 on this side. So let's go ahead and subtract 12 from both sides. I'm aligning my like terms, and so I get x squared minus 3x minus 10 equals 0. And at this point, you can try factoring, and these are going to be factorable, or you can use the quadratic formula. It does not matter. But I'm going to go ahead and factor this. So when I factor this quadratic expression that's on the left side, I'm going to get x minus 5 times x plus 2 is equal to 0. And then we know that at this point, I'm going to have to use the zero factor property because I have two factors whose product is 0. So I'm going to set each of those equal to 0, just like this, and then solve each linear equation. So over here I get x to be 5, and over here I get x to be negative 2. Now be careful. So remember, you found some restrictions earlier, right? There's a reason for that. Okay, so notice this equation is a rational equation, but the solutions to this equation came from a quadratic equation. A quadratic equation, see, that equation looks different than this equation. They're not the same. This is rational, this is quadratic. So these are solutions to each of those quadratic equations. But the question is, are these proposed, I'm calling these proposed solutions, are these proposed solutions to the original equation? And all you have to do is look for those restrictions. As long as I did this work correct, that's all you have to do. Look to see if there are restrictions. So what happens is that you have to check for extraneous solutions. So kind of like false solutions. So extraneous solutions are solutions to one of the equations in the process, but it's not a solution to the original. And basically you just look for those restrictions. My restrictions are 1, -1. Are any of these my restrictions? The answer is no. So there are no extraneous solutions, right? So you're going to say solutions are, there are two of them, x equal 5 and x equal -2. Okay? And that's it. That's all you do. All right, so that's an example of a rational equation that led to quadratic equations, just like this. But just like you did in a previous lesson, you have to check for those extraneous solutions, which basically you're just looking to your restrictions. All right, so that's number 1. So let's look at another. So let's look at a couple more. So let's look at number 2. So suppose in number 2, I have this equation. Okay, number 2. So suppose I had 5. Let's do x divided by x plus 2 plus 2 divided by x squared plus 5x plus 6 equal 5 divided by x plus 3. All right, so let's suppose I had that. Okay, so just like we did before, we have to find the least common denominator. Before I find the least common denominator, I have to factor all of those denominators. So if you look at that first factor right here, that's a linear factor, right? And the GCF is 1. Same thing here. X plus 3, the GCF is 1. So there's not much I can do in terms of factoring here. But this is a quadratic expression right here. So when I factor this, and just to remind you about something we talked about before, chances are, with the problems you're going to have, chances are, it's not always true, but chances are, the factors of this quadratic expression will be the factors that you see here. But always verify, but that's not always true. X plus 2 times x plus 3. So if you FOIL this out, you'll get this right here. Okay? So now let's find the LCD. So the LCD has to include every factor that you see in the denominators. So this factor right here has to be part of my LCD. X plus 2. This factor right here has to be part of the LCD. I already have it. Don't list it again then it becomes no longer the least. It becomes a common, and it makes the process difficult. X plus 3, I must use it. X plus 3, I already have it. So my least common denominator is a product of these two factors. Now I've got to find the restrictions. So let's go ahead and find the restrictions. So if you look at the first factor right here, x plus 2, where's that equal to 0? Well, x plus 2 is equal to 0 when x equals negative 2. So there's one of your restrictions. X cannot equal negative 2, because if x were negative 2, this right here would be a 0. And so any number divided by 0 is undefined. The next factor you see is x plus 2. I already taken care of that. The next factor you see is x plus 3. So where's that equal to 0? Well, x plus 3 is equal to 0 when x equals negative 3. So there's the other restriction. And then over here, I already took care of that. So there are two restrictions, negative 2 and negative 3. All right, so the next step now is to multiply both sides by the least common denominator. So let's go ahead and write that down right here. So notice that these two, the left side is two rational expressions. And remember, when you rewrite this one, put it in factored form. All right, so I'm going to rewrite the left side. So I get x divided by x plus 2 divided by, in factored form, x plus 2 times x plus 3. And put that in brackets, and that's going to be multiplied by the LCD. So it'll be x plus 2 times x plus 3 equal 5 divided by x plus 3 times the LCD. Okay, so you'll multiply both sides by the least common denominator. All right, and now you're going to distribute. You can get rid of the brackets that you just put in there, so you're going to distribute now. So I get the LCD, x plus 2 times x plus 3 times x divided by x plus 2 plus the LCD, x plus 2 times x plus 3 times 2 divided by the denominator, x plus 2 times x plus 3. So notice I multiply the LCD by this, and then the LCD by this. Equal, I'm running out of room right here, so I'm just going to go ahead and reduce right away. And so I get 5. Remember, x plus 2 times 1 is x plus 2, so 5 times x plus 2. Just like that, okay? All right, remember the whole purpose of multiplying by the LCD is to clear those denominators. So I've already made this a factor 1, so these better be a factor 1 also. So x plus 2's divide out, just like this. The x plus 2's over here divide out, and so do the x plus 3's. And so notice I have 1 times x plus 3 times x, right? I'm going to put the x in front. So 1 times x is x. I get x times x plus 3. Over here, I got 1 times 2, which is 2, equal, and then let's go ahead and I'm going to rewrite this over. So I'll just write as 5 times x plus 2. All right, so I reduced and I rewrote each of those expressions. All right, now I'm going to go ahead and get rid of the parentheses. Now notice I went from a rational equation with fractions, right? And notice I no longer have fractions in the denominator. But this is quadratic, because if you distribute the x, you get x times x is x squared. You see that? So I get x squared, and then x times 3 is 3x, plus 2, equal, distribute here. I get 5x, plus, and then 5 times 2 is 10. All right, so I have this quadratic equation, so let's go ahead and put this in standard form. So I'm going to go ahead and subtract 5x from both sides, and I'm also going to subtract 10 from both sides, right? So I'm going to do 2 steps in one. So I get x squared, 3x and a negative 5x is a negative 2x, 2 and a negative 10 is a negative 8, equal, and this is 0 and 0, which is 0. Okay. So now I'm going to solve this quadratic equation. It is factorable. If I wanted to, I could have used the quadratic formula, but this is factorable. So I get x minus 4 times x plus 2 is equal to 0. And then setting each factor equal to 0, I get x minus 4 equals 0, x plus 2 equals 0. And then solving each of those linear equations, I get x equal 4 and x equal negative 2. Now remember, these are your proposed solutions, right? So these are the proposed solutions. So I know that these solutions, those two solutions are solutions to each of those quadratic equations. So solution to this, a solution to this, a solution to this, a solution to this. But is it a solution to the rational equation? And so that's where those restrictions come in. So here you have 2 restrictions. So question is, are any of these extraneous? Do I have extraneous solutions? extraneous. And I do, -2. So x equal -2 is not a solution, right? It is extraneous. So the only solution, so you're going to say the solution is x equal 4. That's the only solution. Okay? So always make sure when you transform an equation, in this case a rational, to a quadratic equation, or a linear equation for that matter, you always check to see if you introduce any extraneous solutions. So any solutions that are false. All right, so remember, an extraneous solution is a solution that is a solution to a previous equation, but it's not a solution to the original. All right, so let's look at one more. So let's look at number 3. So number 3. So let's suppose in number 3, I have this in number 3. So number 3, you have 1 divided by x plus 1 plus 4 divided by x minus 3 equal 4x divided by x squared minus 2x minus 3. All right, so then you want to find the least common denominator, so you have to factor all those denominators. So this you cannot factor any further, this cannot be factored any further, but this we can. So when I factor that, and remember the factors here are normally not always true though, but they're normally these factors here. So this should be x minus 3 times x plus 1. But check it, always follow this out to make sure you get this back, and you do. So the least common denominator is going to be it will be the factors that you see here. So I see an x plus 1, I see an x minus 3, I see an x minus 3, I see an x plus 1. So it'll be x plus 1 times x minus 3. So it's a product, right? So don't put a comma there. Now we got to find the restrictions. So what makes this denominator 0? So what can't x be? So x plus 1 is equal to 0 when x equals -1, right? So x cannot equal -1. Over here, 3, x minus 3 equals 0. So x minus 3 is equal to 0 when x equals 3. So there's the other restriction. And then we already took care of that, and we already took care of that. So there are two restrictions, -1 and 3. The next step is to multiply both sides by the least common denominator. So I'm going to put this in brackets right here since there are two fractions on this side. So let's see. So it'll be the least common denominator times the times 1 divided by x plus 1 plus 4 divided by x minus 3 equal. And then the least common denominator, x plus 1 times x minus 3 times this fraction here, 4x divided by, and don't write it like this, write it like this, the one that's in factored form, x minus 3 times x plus 1. And the reason is because you can see right away that those factors here will divide with these. Okay, the next step is to distribute. So I get x plus 1 times x minus 3 times 1 divided by x plus 1 plus x plus 1 times x minus 3 times 4 divided by x minus 3 equal. And since I'm running out of room, I'm going to go ahead and reduce all of these. So all these divide out. So you got 1 times 4x is 4x. Reducing over here, the x plus 1's divide out. Remember the whole purpose of multiplying by the LCD is to get these denominators to be 1's. And now I have 1's there. So I have 1 times x minus 3 times 1. So that's easy. 1 times x minus 3 times 1 is x minus 3. Plus, now be careful here, I have x plus 1 times 4. So 1 times 4 is 4, right? I'm going to put the 4 in front of the x plus 1. So it becomes 4 times x plus 1 equal, and then 4x. Okay? All right, so that's where I'm at. Okay, before I go on, I made a mistake here. This right here should be an x, excuse me. That's an x. That's an x, but it's not going to change much. So that's an x, right? And this is an x right here. So put an x right here. Okay, so I made a mistake. I apologize. So that's an x, 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 x. Okay. All right, so that's where I'm at, right? Okay, so now we're going to distribute right here. So when I distribute, look at what I get. I get x minus 3. Okay, x times x is x squared, right? x times x is x equal 4x. All right, so that's where I'm at. So notice I went from a rational equation to quadratic. Okay, so let's go ahead and solve this quadratic equation. Let's combine like terms first. So I get x squared. X plus x is 2x minus 3. So all these when I combine is this, equal 4x. So I got to put this quadratic equation in standard form. When I do that, I'm going to subtract 4x from both sides. Notice I'm aligning my like terms. Combining my like terms, I get x squared, 2x, and a negative 4x is a negative 2x, minus 3 equal, and then 4x minus 4x is 0. All right, so I can use a quadratic formula at this point, or I can try and factor, and it is factorable. All right, so it's now in standard form. So when I factor this, I get x minus 3 times x plus 2 is equal to 0. Setting each of those factors equal to 0 using the zero factor property, I get x to be 3 and x to be negative 2. So remember, those are your proposed solutions, right? I'm sorry, this right here should be 1. I am making little errors, aren't I? All right, so that should be x minus 3 times x plus 1, not 2, because 3 times 2 is 6. That's a 3. So that should be 1. So 1 and negative 1. All right. So those are my proposed solutions. 3 and negative 1. Proposed solutions. Okay. All right. Now, those are my proposed solutions. So I got to check and see if any of these are extraneous. And all you do, so before I go on, remember those solutions are solutions to this quadratic equation, this quadratic equation, this quadratic equation, this quadratic equation. All right. So notice when I factored x squared minus 2x minus 3, I get x minus 3 times x plus 1. All right. And so if you follow it out, you'll see you get this back. Setting each factor equal to 0, I get these. So these are solutions to this one. Question is, though, are these two solutions to the original, which was a rational equation? And so you got to check and see if any of these are extraneous solutions. So I have a 3 and I have a negative 1. What do you notice? They're both restrictions. So both of these are extraneous solutions. Both are extraneous solutions. See that? Well, since both of those are extraneous solutions, then none of these proposed solutions are solutions. So you're going to say the answer, you're going to say there's no solution to the original equation. So no solution. So the original equation has no solution because both of my proposed solutions are extraneous. Both of those are restrictions. Okay? All right, so that was 3 examples that should help you with the problems that look like that. Just know that I did make a mistake here, so I put a 4 instead of an x. So that should have been an x. So you just put an x here, put an x here, put an x here, and then when you distribute, you get quadratic. And then you factor, and when you factor this, you get x minus 3 times x plus 1, right? And then set each one equal to 0, and those end up being your proposed solutions. Both end up being extraneous because both of those are restrictions. So therefore, you have to say the original equation has no solution, meaning this right here has no solution. Okay, so that is how you're going to do the work for those problems dealing with this. It's quite a bit of work, right? Quite a bit of work, and be careful as you go through the process because as you can see, if you do things quickly, you could easily mess up. So when you write down the problem, just like I did here, be careful to make sure you write down the problem correctly, because in all this, if you don't recognize it right away, all these will be incorrect. Okay, so good luck with those problems, and do the best you can.